Yeah, today is an interesting topic in computer vision. Okay, it's called detect objects in real time. Okay, and what we'll talk about is what is computer vision and what are the various facets of computer vision and how we can actually build an application which can help us detect objects in real time. Okay, so again, if you look at uh, why we need to detect objects in real time, right? Can someone tell me any practical use cases? Nagesh, are you aware of any practical applications where you think computer vision can be useful? Any quick thoughts? Yeah, you can unmute and speak. I think we have less people, so we can make it a little bit interactive. Yeah, Nagesh, any thoughts?
No, I think.
Okay, you're not able to think of anything, huh? Okay, okay. No problem. So computer vision basically is required in fields. I'll tell you. Have you traveled by aeroplane, Nagesh? You might have traveled
No,
by
no,
aeroplane, right?
no, no,
Huh?
no.
Oh, you never traveled by aeroplane? Okay.
No.
Yeah. You never traveled by aeroplane, Nagesh?
Yeah, no.
Oh, okay, okay. So if you travel by aeroplane, again, pretty much in airports nowadays, you have something called DigiYatra, right? Have you looked at this? I'll show you. So do you know what is DigiYatra, Nagesh? Any idea? Okay, no problem. So if you see in airports, again, since you've not traveled, I'm trying to show you one image of how it looks. So I think Kirtana, have you traveled by aeroplane? Okay, can you see this here? This picture,
Yeah,
right?
yeah, yeah.
So I'll just minimize this. So this is what is there in Indian airports. Okay, it's not even foreign. It's Indian
Oh,
airports. I'll
okay,
just click on this. So the next time when you go to an airport, you can see this, or when you're going by airplane, you must enable your DigiYatra. So if you see here, please scan your face. It's saying, right, please scan your face.
okay,
So you just need to go and stand in over there, and that's it.
okay,
It will just allow you into the airport.
okay,
Okay. So you don't even have to present your Aadhaar card. You don't have to present anything,
okay,
right? Just stand in front of it. It will recognize your face and it will say that, okay, of course, you should do the pre-setup for this, right? There'll be a DigiYatra app where you will have to register yourself in that before you come to the airport. Okay. So
okay,
what it is doing here is basically in real time, as soon as you're standing in front of it, it will identify your face. It will say that, okay, Nagesh is the person who has registered with DigiYatra, in the app. So this face matches. So I think I can authenticate him and let him go. Okay, simple as that. So this is one of the most useful practical scenarios of computer vision. Okay,
okay,
computer vision means the ability for machines to identify people without manually having someone to do it. Okay,
okay,
so that's the one of the most important aspects, right? And today
okay,
what we're going to do is real-time object detection using computer vision. Okay, so what we are saying is I want the machine to be able to identify people, should be able to identify objects, and so on and so forth. Correct. So if if a particular object is a say a mobile phone, it should be able to identify as mobile phone. If it is a person, it should be able to identify as person, and so on and so forth. Correct. So that is what computer vision is. And computer vision, if you see the definition, is a field of AI. Okay, so AI has multiple fields. One is in NLP, which is natural language processing, computer vision, which is CV, and a few others, reinforcement learning, and all this. But in computer vision, we are enabling machines to interpret and understand visual information from images or videos. So if I give you a particular image or a video, you are allowing machines to interpret and understand that visual information by themselves and help humans in a particular way, like DigiYatra, correct? It aims to replicate human visual perception, right? So basically detect, classify, and make decisions from visual data. So in DigiYatra, which is identifying, allowing people inside, but there can be other applications. Like for example, in like you will also see in your mobile phones, right? I don't know if you have a mobile phone which has that, but if you just look at it, it will identify you as a person, as the owner of the phone, and it will unlock, correct? So that
yeah.
is also
The
vision.
screen lock.
Okay.
You are
Yes,
saying
screen
that.
lock.
Yeah,
Yes. So that is also a good example. So all these are examples of computer vision which will help us in using AI for detecting objects or people. Okay. Now, again, another example of computer vision is also where in China, right? In not only China, in advanced market, I'll show you in YouTube. They use separation separation of tomatoes using AI. Okay. So if you see, they use AI. If you see this, can you see this? Automatic tomato separator. Can you
Yeah.
see this?
Yeah. Yeah.
So on the fly, it is immediately removing the ones which are in green. So this is a very good example of how computer vision is used. It automatically sees which is red, which is not red, and immediately moves and does the needful.
Okay.
Okay. So these are the
Based on the
examples of
color, it will be differentiate.
yeah, sorry, what's that?
Based on the color, it will be
Yes,
differentiate.
yes, yes. Based on the color, it differentiates. If it is not green, if it is not red, then immediately the machine will pull out that that lever, and it will pull out that fruit.
Yeah.
Correct. So
Yeah.
that is the those are the benefits. Now, why does computer vision matter? It automates visual tasks which humans do manually. It powers the real-time decision systems. Okay, like you saw right now for the tomatoes, used in healthcare, autonomous vehicles, surveillance, retail robotics, and more. So one of the other examples of again computer vision is in autonomous cars, right? If you know, do you know about autonomous cars in US? Okay, so like you have Waymo, right? So in US, this is called Waymo, right? Uh, so in US, there are these taxis which drive by themselves. They don't have humans in them. Okay, so this is actually really there in US. So this particular car will be completely controlled by AI, right? If you see the
Okay.
entire setup, it has multiple cameras on all sides, correct? It uses the cameras on all sides to detect what's going on around, and there are models which will dynamically detect and they make decisions on the fly based on what information it is grasping from each part, correct?
Okay.
And then it will just keep moving based on that, right? That's how it works. Okay. So there are a lot of such retail use cases. I won't go into them, but let's get going. Okay. So how computer vision works? Basically, images, whenever these images are coming, right? Now, computer cannot understand images. It can understand image pixels or numbers, correct? So all the images are converted into pixel matrices. So even what you're seeing on the screen here, this big screen that you're seeing on my screen, is converted into small pixels, right? And that's when it is relayed. Even your laptop can renders it as each pixel consisting of specific set of colors, RGB color, correct? So every small thing that is there in this entire screen is consisting of pixels, correct? Now, what happens after that? Once you convert it to pixels, the neural networks learn patterns, features, and textures, right? So there's a neural network which learns the patterns and identifies, okay, what's going on in this, and then it learns from that. Okay. Now, models are trained using large labeled data sets. So what are labeled data sets? Basically, data sets of images which are labeled. For example, if I have a red tomato, if I have an image of a tomato, I label it as red tomato. If I have an image of a green tomato, I label it as green tomato, correct? If I have a green carrot, let's say I'll name it as green carrot. So what what happens is all these images are converted into pixel matrices, and the neural networks then are being trained on top of it to say, if you have a red tomato, this is how it looks. If you have a green tomato, this is how it looks. Now, this is the composition or the distribution of your pixels for a red tomato versus a green tomato versus a red carrot, correct? So that when it sees a new object, when it sees a similar object again, like in DigiYatra, when you saw the human again, right? It immediately recognizes it. How does it know it? Because it is comparing the human's pixels in the database, right? And that it is happening in real time. Okay. So object detection, again, some of the concepts of computer vision are applicable to help in detecting things in real time. Okay. That's how it's useful, right? And you train a model based on all these patterns, features, and textures, and then we go and detect. Now, what are the output, right? The output is nothing but prediction like class labels, bounding boxes, mask key points. What are the key stages in a computer vision pipeline? Okay, so the key stages in computer vision pipeline are what data collection, okay, pre-processing, okay. Pre-processing involves resizing it, normalization, and augmentation. Okay. Then you have the model training, the core model which is trained, and then you have inference, basically nothing but the prediction. Inference is prediction. And then you have the post-processing. Okay, so what happens after the inference is done, then what happens? Okay, it's thresholding, filtering, and visualization. Okay. Now, image classification. So what's in this image, correct? So typically, in computer vision, you have something called classification. Okay. Now, classification is basically going to say I know the topic is object detection in real time, but I also want to talk a little bit about classification, object detection, and segmentation, which are integral parts, three different parts and integral parts of computer vision. Okay. So image classification basically says what is in this image. Okay. Is it a cat or is it a dog or is it an airplane? What exactly is that? Okay. So you assign a single label to the entire image. So you say, in this image, I can see a cat or I can see a dog or I can see an airplane. Okay. So basically, where is it used? It is basically used in or the tomatoes thing example. It immediately says, okay, is it a green tomato or is it a red tomato? That's it. So that's a classification by itself. Okay. It may not always be completely different like cat and dog. It can also be red tomato, green tomato, right? So medical image diagnosis, again, here also it's important because you want to identify, let's suppose, is there a cancerous cell or not? Is there a tumor? Yes or no, right? So that is how classification also helps. Your product categorization, you want to identify various categories of products. So that's where image classification helps. What are the various types of image classifications? You can have binary classification, right? Basically, you're saying binary classification means you have only two classes primarily, like is it a cat or a dog, right? One of these two classes. Multi-class classification could be a cat or a dog or a car. So it's multi-class classification. Multi-level classification, which says multiple classes can be present in this. Okay. So what are the various models which are used? You can use CNNs. Okay. Convolutional neural networks. You can use ResNet, right? You can use efficient net. You can use vision transformers. Okay. VIT. Next is object detection. Okay. So earlier we talked about image classification. Now we're talking about object detection. So this is another branch of computer vision. Okay. So object detection, again, our topic is object detection. Okay. So object detection is basically saying, hey, I'm not going to just do classification of an image as whether it's a cat or a dog, right? And I'm actually going to tell you what is that particular box within that entire image, which is present, in a particular image. Like suppose you have taken a photograph of your class. Okay. So if you take a photograph of your class, what will happen? There will be students in that. There will be benches in that. There will be maybe some photos on the background of the wall, right? And maybe there will be some laptops, I don't know, whatever, tube light, and whatever other things are there in your class, correct? So, sorry. What object detection is going to say is it will draw boxes around each of these objects in that particular image. Okay. So the goal of this is to identify what objects are present and where are they in a particular image. Okay. So in the case of a class photo, if the objective is, hey, identify where the fan is, right? It will exactly draw a box around that fan. Okay. So that is called the bounding box coordinates or the bounding box, right? So it draws a box around that particular fan and it says that the fan is exactly at this spot. Okay, so this is different from classification because it is not telling you, is it a fan or is it a tube light? It's not telling you that. It is telling you that what are you interested in? You're interested on the fan. Okay, that's what it's all about. Okay, now why is this important? Why is object detection important? Because it is has application in autonomous driving, surveillance, and retail analytics. So how can it? Why does it have applications in autonomous driving? Because like I showed in the picture of Waymo, right? If I show you the picture again of Waymo, Waymo, so driving image. So typically when you drive a car, like can you see this here? If you drive a car, you see that the car is going on the road and the car has to identify various signals on the road, correct? It has to, when it sees traffic signals, correct? Traffic signals, it has to know, is that a red color, orange color, or whatever it is, correct? Next thing is, suppose if you look at this image, it is saying that right side is not allowed, correct? Can you see this image a little bit big? It says clearly the right side signal says on red, don't go to the right side, correct? Or whatever the signal is, correct? So it should be able to say in this whole image, see, when we see as humans, we focus on one particular thing, which is this one, correct? Now, even the car, if it has to drive, it has to focus on what it sees in the entire screenshot that is provided from the camera on top of it. Okay, so if you see this Waymo, it has one camera on the left side here, one camera on right side here, one camera in the center, one camera over here in the top. And in the top also, you will have multi-directional cameras, correct? Now, each camera is giving multiple photos to that entire car, the entire AI model of that car. Now, when that photo is coming like this, imagine the photos looks like this. It should be able to say in this particular photo, what are the various objects? Can I see traffic signals anywhere in this, correct? So that is object detection, right? It sees that, hey, I can see one traffic signal over here, and that is on red. Okay. I can see one more traffic signal here, which says right lane must turn. So if you're on the right lane, the car should do that, correct? And then you have one more thing here, which says some post, something like that. Something is there, something is, I can't see it clearly, but it also has. So what object detection does is get me all the signs on the road which are there so that I can analyze those and then make a decision based on what I'm supposed to do. So what is the objective here? It's an autonomous car. That means there are no humans driving the car. So if there are no humans driving the car, it should be very, very perfect with respect to what signals are there, what boards are there, and it should be able to correctly interpret them. Now, to correctly interpret them, it should write a bounding box. This is the bounding box. This is the bounding box. This is a bounding box. So these bounding box coordinates are retrieved, and the content in that particular bounding box is then analyzed for the various business use cases for which we are building this application. Correct. So this Waymo car will look at the information in these bounding boxes and make a decision on the fly. So that's why it's important for object detection in autonomous driving. Same thing again with surveillance and retail analytics. You can apply this over there too. So what are the various types of object detection, right? You can have one-stage detectors, which is YOLO or SSD, or you can have two-stage detectors, okay? So again, the applications are, again, in tracking, counting, robotics, people detection, and so on and so forth. The third pillar of computer vision is segmentation, okay? So segmentation is basically saying that I don't care if you are a cat or a dog. I don't care where in the object it is there. I want you to draw a boundary of the object. Okay, so I'll just show you some examples of segmentation examples. Okay, in computer vision. Okay, so if you see here, segmentation is basically like you can see this is a classic example. Suppose you have a tiger. Okay, and you want to do segmentation of a tiger, this is how it gives you. The output of a segmentation output is like this. Okay, so the output of classification, again, you can look at another example here, which is provided here. Okay, I'll just zoom it a little bit. This is a good example. So object detection is like this. You can see various dogs, correct? Which dog is where? This is one dog, and this is a cat. That is object detection. Classification is second example, right? Is it a cat or a dog? So this is a cat, so this is a classification problem. The third one is segmentation. Segmentation basically says, I'm going to give you the boundary. See this cat which is here is going to give the boundary of that. That's segmentation. Here also you can see this boundary, that's the segmentation. Okay. So it is going to tell you and going to fill the entire pixels within that to tell you where it is. So a bounding box basically will give you extra stuff outside. You see this grass is also there in this cat. But a segmentation will give you the exact boundary of that. And one of the best use cases is in Photoshop. If you remember, back in the day, we used to have Photoshop. If you select a person and select on it, it will select the entire boundary of the person. So these are some of the algorithms which have been used from a long time now. Okay, it's not like it's completely new. Some of them have been used from a long big picture, again, if you look at it in summary, what are the three types? One is classification, detection, and segmentation. Okay, classification basically says what is in the image. Okay, object detection says what is there and where, and segmentation says what, where, and exact pixel shape. That's what we saw for the dogs, correct? So computer vision powers real-time intelligence systems across industries. Okay, and understanding these three core tasks builds the foundation for all advanced computer vision applications. Okay, so any questions still here, anyone? So let's get going. Okay. Now, real-time object detection. I think that's a topic for today's session. So real-time object detection, by the end, you'll understand how AI works without internet, and we'll see a live demo that you can build yourself. So what we are doing in this demo and this application is we are trying to build a real-time object detection application, which will not require a specific LLM or anything outside of our system. Okay, we don't want to be dependent on anything. This application which we are building should be able to run as a standalone application without having any kind of interaction or call being made to any LLM outside. Okay, so that is what we're talking about when it's a real-time object detection using Edge, right? Now, what I will do in this demo application in a short while from now, maybe in around 10 minutes, I will start showing that is how we can build a computer vision application using YOLO V8 to detect some objects in real time. I will show you how it will detect a phone, how it will detect a book, and so on and so forth. Okay. And also humans it will detect. Okay, so I'll show the demo of that shortly. So how does it happen, right? So basically, your image detects faces in 0.1 seconds. Okay, so This is a question for all of you. How does your laptop recognize faces instantly? Does it send data to server every time? No. How fast does the data processing happen? It happens in real time. Okay. Now, what we'll do is in today's application, we are going to give a demonstration of how this is being done. Okay. So what is object detection? I think we covered some of these points. So visual comparison, left side image classification, right side, and all this we covered it. Let's move on. So what we'll do is in today's demo, right? Again, I told you the basics of what is classification, what is object detection, and what is segmentation, right? So today's focus is object detection, and what we'll do is we'll build an application using YOLO V8. And how many of you have ever built an application using YOLO V8? Has anyone built it before? Anyone? Has anyone heard of YOLO V8? Anyone? You can use the chat window also. You can use the chat window also if you have used it. Anyone? Has anyone heard of YOLO V8?
No.
Okay, fine. So no problem. So yeah, what I'll do is again, YOLO V8 is a popular AI model for detecting images and video. Okay. So the core purpose is the app runs object detection on your webcam. Okay. Feed in real time means I'll turn on the webcam soon and you will see that my application is able to I think someone put a message. It's an object detection model. Yes, that's right. So yeah, it is. Yes. So what I'll show you soon is how we'll build an application which will run and detect my face. It'll detect my phone. It'll detect my Kindle also and all that, right? So it's designed as an educational demo for your college freshers workshop. And okay, so this is how you can run efficiently. Now, what is the walkthrough of this? Okay, so the high level walkthrough of this is that there is an object detection app class, okay, which is the heart of the application, okay. So what I'll do is I'll open the code and I'll show you the code so that you get an understanding at a high level what's happening. Because you can always run the application, but if you don't understand what's going on, then you'll not know what's going on, okay. So this is the code which is there over here, okay, on the last page. You can where's that thing gone? Okay, it's just engineering, right? So you can say git clone until there and you'll get this application. Okay. So here what we are doing is we are importing the YOLO. You can see this from Ultralytics. Okay. So YOLO is imported from Ultralytics and this is the main application with the main class. Okay. And here you see dot PT, which various models that I use. Okay, which model do you want to use? Okay, and what we are saying here is, okay, so the initialization loads the YOLO V8 model, and you can choose nano, small, medium, or large depending on speed versus accuracy trade-offs. Okay, so if you see, you can see this nano right over here. There are various points, right? Various models you can use YOLO V8 dot PT 8S, 8M, and 8L. Correct. So different models you can use. And you just need to specify which model you want to use in this. Okay. Now, which model you use is a function of what kind of trade-off you're willing to accept, speed versus trade-off. Okay. The nano version is just 3 MB and fastest for demo purposes. Okay. So you have the nano version, it's the fastest. Okay. You can also set a confidence threshold there. This controls how sure the model needs to be before detecting the application. Okay. So at 50%, it balances catching real-time objects without too much of noise. Okay. So this is a confidence threshold which you need to set, and that is going to be like if you set it at 0.7, it is strict. Okay, so fewer false positives. That means fewer false positives means it will make fewer mistakes. Okay, but it might miss out a lot of the things that from the object. Correct. So if I show a given video, right, or an image, it will capture some, but since it is not sure, you're saying be very strict with respect to accuracy. It will say whatever it is very sure, 0.7 confidence and above, it's going to detect it. The rest of the things it says, I don't know, because you want a very high confidence. But if you want, if you say 0.3, right, 0.3 is loose, right? That means your confidence level is set very low. That means it says, even if you're not very sure, no problem, go ahead and give me, tell me that this is whatever it is, whatever you think, you just tell it, correct? Just detect something and tell me. But the problem is it says more detection, which is correct. That is, it will be able to detect more objects, but it is going to say some noise is also going to be there. Okay, why? Because some of them it may not be sure, but still it is going to detect. So you might see stuff which it says is a, let's say a book, but then it's really not a book because it's just thinking it is a book. Okay. So 0.5 is default. It's a balanced thing. Is generally that's what is considered. Okay. Now, the calculate FPS method tracks performance by measuring how many times, how many frames per second, by measuring how many frames, averaging over a rolling window of 30 frames to give you a smooth FPS counter rather than jittery frame by frame numbers. Now, FPS is frames per second, right? So what happens is every video that you see is consisting of multiple frames per second, which are played in sequence. That's how you see the moving effect, correct? So here what we are saying is we define the FPS. Calculate FPS is one function which is over here. Okay, it calculates frames per second with averaging. Okay, so this logic is returns the average FPS over the window that is being considered. Okay, the add info panel methods overlays helpful information on the video display. So suppose on the video you want some additional information to be displayed, correct? So where is that over here, correct? So suppose you want to show how many frames are being FPS, what is FPS being considered for this particular object detection? It will show that, correct? And it will also show anything else that you want to display on the screen for that particular requirement. Okay. So I'll show you shortly. What we'll do is we'll try to I'll show you the application, how it works. Okay. In another by 7:15, I will start it. Let me just go a little bit of theory more. So I'll show you how it can detect the video of mine very accurately. And then, you will be able to appreciate it better, what I'm talking about. But here, what we're talking about in add info panel is that we are going to display the information of that particular video or image on the UI. Okay. So the run method is where actually, the main thing that runs, it opens the webcam, it continuously captures frames and then feeds each frame to the YOLO V8 model for inference. Okay. So like I said, every model has inference and it continuously takes the frames and passes it to the YOLO V8 model, and YOLO V8 model continuously draws the bounding boxes. That's what we saw in object detection, and labels around detected objects. Whatever detected objects, it labels them, and you get several keyboard controls, right, to work on that particular video, right? Now, the print statistics method is basically displays a summary when you're done, right? Total frames processed, total detections, average objects per frame, and a breakdown of which types of objects were detected most frequently. Okay. So again, the other thing is, this is again the walkthrough of the logic. We are saying that this OpenCV is another powerful library. Okay. So this is also used for computer vision tasks, and CV2 is the binding Python binding for OpenCV. Okay. So basically, again, this is providing us with a lot of interesting libraries, okay, for interesting methods for us to use in our computer vision project. Okay, so CV2 is the Python binding for OpenCV. OpenCV is a very powerful computer vision library. Okay, so let's say we have CV2.rectangle. It can help us draw a shape of a rectangle. Okay, so if it is a resize, it's going to change the frame dimensions, right, on real time. So whatever you have, it will help you control that using these function methods. Okay. Next is from Analytics import YOLO. So you're importing the YOLO model. So YOLO stands for you only look once. Okay. So this is a real-time object detection algorithm. Okay. And Analytics is the official implementation library. Okay. From where you kind of import it. The YOLO class loads pre-trained neural network models. So it'll load all the pre-trained neural network models. And these models have also learned to recognize thousands of object types. Okay. Now, some of the model sizes available are YOLO V8, Nano, YOLO V8S, small, medium, and large. So I think we have already seen in our code also some of these which are there. Okay. Now we import the time function again in this. So it returns the current Unix time stamp from Jan 1, 1970. So used to measure time between frames for FPS calculation, right? So what of the logics again? You're saying import sys. Okay, it's a system module. Okay, and your double-ended queue for data. So again, we won't get into this, but FPS is the most important concept. Frames per second is most important in terms of how we control the model from accessing that information. Okay. The next thing again, these classes and all, I think are a bit too much for you. We can probably skip them. Yeah. So default parameters are, so we are using YOLO V8 n YOLO V8 n.pt. If the user doesn't specify a model, okay, like here, then use YOLO V8 n.pt nano or nano, which is the smallest or fastest. Okay, PT extension is basically PyTorch format. Okay, So those who don't know, PT is PyTorch extension format. Again, we are setting the confidence threshold, which I already mentioned before. So the confidence threshold is set to 0.5. So if it is defaulted to 50% and objects below this confidence percentage won't be displayed. If confidence is 0.7, only objects 70% plus certain are shown. Okay. Then again, we have the Python display size is 1280 by 720. So we have tuples of width and height. Okay. So Python has an FPS window of 30. Okay. So we are setting the FPS window of 30. 30 means I can average FPS frames per second over last 30 frames. Okay. Now, at 30 FPS video, it gives 1 second rolling average. Okay. So you get that 1 second voila effect on the UI. So when we access it and by degree 1 second corresponds to 30 FPS. Okay. So FPS again is an important concept. Again, that's why I'm just trying to spend some time here. The FPS calculation basically says frames per second indicates performance quality. Okay. And 30 plus FPS is basically smooth video. If you go for anything less than 15 FPS, it is laggy and jerky. Okay. So again, you have this calculate FPS function, which actually takes care of that. Okay. Now, what are the key features of this particular application? The application is interactive, okay, letting you adjust confidence thresholds without restarting, okay? Now, it also tracks statistics throughout your session, which means that continuously as the video is happening, you are continuously able to get the information about what is happening in that video, right? How many frames per second are we showing, correct? What are we detecting in real time? It's not like you have to stop it and then you have to wait for the image to be loaded and then do it, right? It's all happening in real time. Okay, so error handling is built in, and for some reason, if your webcam isn't available or if the model fails to load, you get an error message. Okay, so the code is also educational with detailed comments and doctrines explained. Correct. So I'll share the repo. Okay, so there's a GitHub repo over here, which is mentioned in the PPT also. So I'm going to put this over here. Okay. So this particular code is there in this repo, and I think Data Valley team can share this PPT with you if you request them. So this particular repo has all the code and all the instructions also in terms of what you should do to download this code and execute it. Okay. So if you look at it, it has the instructions like pip install and running the simple object detection file and so on and so forth. Okay. So it has all these details. So I would strongly urge you to go through this and execute it, right? It has also the steps in terms of what are we doing, what is edge computing, how are we doing, what are CNNs, YOLO V8, code walkthrough and all that, right? So I wanted to do this live as a demo for all of you, but the point is some of these libraries take a lot of time to install, okay? So what I will do is I will just go through the code for you, okay? So that I will go through the steps which I followed. I think they are out of this over here. But if some of you have been following the sessions which we have been doing recently, what you can do is first you create the virtual environment. So this is again constant for all the projects. I think all of you know how to create the virtual environment. No problem there, correct? Now, once you create the virtual environment, you will run pip install -r requirements.txt like you always do. And in this one, there is no .env file because we are not making any call to the LLM or we don't need any API key here, correct? So that's why we don't need the .env file here, right? Now we just run pip install -r requirements.txt. So you see that there are a lot of libraries over here which are being packages here which are being installed, right? Like Ultralytics, OpenCV Python, NumPy, Pillow, right? Again, this is for image processing, and this is for visualization, Matplotlib. Okay, so all these are there, and all of them take a lot of time, and have taken a lot of time to install them. That's why I'm not doing this again in real time. Okay, but what I will do for sure right now, because this is all standard practice, there's nothing for you to learn in this, correct? Again, I think if you're not sure how to use Visual Studio Code to kind of clone it and open the folder and clone the code and then run it, then I think you look at some of the previous videos which I have done so far. Okay. Here, what we are saying is I pull the code and I get going from there. Okay. So if you see here, I'm saying there is this file called Python object detection demo.py. Okay. So where is this file? Object detection demo.py. So this is the main file. And what we do is we'll say Python space and run this particular file. Okay. So whatever code is there in this particular file, it will be executed. Okay. Now you'll soon see that when I run this, it is going to download whatever it has to download in terms of, I think, YOLO V8 or anything else. and then it will execute it, and it will show my camera, and it will show how it is able to detect stuff on my screen. Okay. So before we move on, till here, any questions, please? Yeah, I think Surya answered. It's an object detection model based on deep neural networks. Anybody, any questions till here? I'll just give a minute. Okay, good. So what we'll do is now I'm going to run this. Okay. So I'm running this in front of you. So it's going to detect my, it's going to run the Python object detection demo.py. Going to pull up that model. It's going to load up all everything. It's going to take maybe 5 to 10 seconds. Yeah. Can you see this? So I think it has been able to detect it. Okay. So I think, it's working fine. So let's see if it can detect, let's say, a phone, right? Can it detect a phone? It says cell phone. Can you see it? It's able to identify the cell phone. That's great. Let's put some of the other objects. So for me, it's identifying as a person. You can see, let's put a Kindle out there. It says it's a laptop, right? It's not sure. So I think, again, it's thinking it's a laptop. That's fine. Let's see if there are any other books. I don't know if we can identify a book per se, if it has been trained on a book. So it has been able to identify a book, right? Can you see that confidence level on top of it? Right? So if you see it, it's identifying positively as a book. Although, yeah, you can see that it's saying book versus laptop. Slightly, it's getting confused, but mostly it's saying it's a book. Okay. So let's say, I don't know, computer mouse. Can identify a mouse? There's no mouse. Yeah, it's thinking it's a remote. So I don't know, it's not properly trained on that, but it's okay. So end of the day, it's not perfect, correct? So what I wanted to say is, it's not a perfect way. If you see at the background, right? Can you see this? It's continuously scrolling in the background, right? This, if I minimize this, the background, you can see this, how the text is continuously rolling up, right? It's continuously having so many frames per second, continuously the data is going and it is continuously printing it. Okay. You don't have to print it per se, correct? But it's taking it at 123, 120 milliseconds, right? And it's saying what is the size of that image and what is the post processing for the image at that particular shape, correct? So that's how, again, if you open this, again, you can see it's continuously detecting. If you see on the top left, this is what I was talking about in terms of information that you display, correct? So we are saying if the frame per second is 9 or 10 frame FPS, this is the 1150 frames. That means so far 1000, 1100, 1200, and again, whatever, it's continuously increasing. So many frames are continuously being shown, right? So there's only one object is what it's saying. But let's say I put in, let's say this Bluetooth case, right? So can it detect the Bluetooth case? It's not able to, right? Maybe it doesn't know it, correct? So some of the things is also dependent upon what is the confidence that we want to set, correct? If we say we want too strict, let's say 0.7, then it will not be able to detect, right? So let's say if you put a hand, it will detect a hand. Yeah, it's still not able to detect it, right? Maybe. So one of the things is, so let's say keychain, will detect keychain. Yeah, it's able to identify common objects like book and phone and stuff like that. So thing is, why is it important? I'll close this. Okay. Yeah. So immediately if you see, I think it's still running. Yeah, it's continuously opening it because I didn't close it. I have to close it from here. Okay. So if you can see, it is going to give you a summary of what are the various objects that it has detected, right? So it said it detected a person 88% of the times. Out of all these, in all these frames, laptop, it detected 92, 4%, laptop, then book, then cell phone, remote. I don't know. It said cat also. I don't know. There's no cat here. It said umbrella too. It said couch too, because in the background there's something like a couch. I think bird and TV. There's no TV, but there's a bird. I don't know. There's a small toy or something. Right. So it also gives you a summary of the model configuration. Like the model name is YOLO V8 Nano. Right. The model size is 3 MB, just 3 MB. If you look at it, right, so small. The confidence threshold is 50%. That's what we set it at. The display resolution is 1280 divided by 720. Okay. And if you see the terms and stuff at the back, the total frames processed is 1877. The total detections are 2206, and the average objects per frame is 1.18. Right? So pretty much 1.18 is again nearly just one object has been detected per se. And that's what it is all about. Okay. Now, again, it's saying interrupted the user because we just stopped the application from running after a certain point in time. And if you see the other things, what is there? Again, it is saying 1% and speed, pre-processing, post-processing, and all that stuff. Okay. So, so yeah. So again, if we get back, any questions here? Anyone? Yeah. So if you want to run this particular application, your code is all here, right? I have not. So you can also try it out. Okay. The steps are also mentioned here in detail in terms of how you can run the application yourself also. So all you have to do is pip install -r requirements.txt. Okay. You download first, you clone this whole entire code. Okay. Now, once you clone the entire code, you will get the code into your local like this one. If you can see, this is all the code, object detection real time. Okay. All this code is here. In this, the main important thing is, again, you can see is YOLO V8 underscore PT is again PyTorch. You can see that we have object detection demo.py. This is the main file which I ran right now. Okay. And you can go through this code and try to understand or ask ChatGPT or Claude to explain what exactly is happening in this particular piece of code. Okay. And pretty much that's it. You don't have to do anything else. So rest of the stuff is more like, again, for reference and all the other stuff, right? So there is also something called Python minimal underscore demo. Let's just see if this works. .py. Okay, so what you should run for the sake of this is, yeah, I think this one is a much more simpler version. It does not give any jazz like the other one in terms of all the statistics and metrics and all simple frames per second. So let's say if it's able to detect the phone, yeah, it's not really very powerful, right? It's saying it's a remote, correct? So let's say if we can detect a book, right? Again, it's saying cat and all that stuff, right? So, but anyway, so this is a simpler model, just to kind of give you the illustration of how the object detection dialog shows up and how it kind of renders it. Okay, so just need to compose this. Okay, so you don't have to worry about that. So go ahead and run this object underscore detection underscore demo.py, and that should be able to kind of help you with get what you want. Okay. So that's the thing about this. Okay. And any questions, anyone? Found useful, right? So so in the PPT, again, when you go through the PPT, I would like you to kind of focus on, again, what are the key features in this. What we are building is the app is interactive, letting you adjust confidence thresholds, again, without restarting. Okay. I think so I think we covered this slide. So basically what's happening is when you run it, the app initializes, downloads the YOLO V8 Nano model, okay, opens your webcam and displays a live video stream with labeled objects. So what it is doing is, it is not just running the model, it is actually controlling the hardware too. It's also controlling your webcam to kind of show the video, capture the video from the webcam, transmit it, relay to the YOLO V8 model, and then label it in real time. Okay, so every detection contributes to running statistics that get printed when you quit, right? So again, statistics, I showed you how many frames ran and how it ran and all that. So the performance is fast enough to run smoothly on a laptop because the nano model is very lightweight. So now, if you take up a very powerful model, the system can hang, right? So we picked up a small model, which is the Nano, YOLO V8 Nano, and that's why it works smoothly. Okay. So this is how it is working. Okay. Demo application, which I would encourage all of you to kind of go through and run through in your systems. Okay. When if you kind of install it on your system. So how many of you have run any application using virtual environment? Are you people comfortable with actually creating the virtual environment and running the applications in the virtual environment? How many of you have done it already? Anyone worked on it? Do you need help on how we can? Do you want me to show you how we can do it? If you need help, I can do that. Okay. So anyway, I didn't hear back, but still I will explain that so that you people can understand how it works. Okay. So so what I'll show you is this is important because if you are trying to run this project on your own, you may not be able to work, right? It might not work, it might throw errors or whatever it is. So in typically any Python project you have, the first step you have to do is create a virtual environment. Okay. So how do you create the virtual environment? So you go to any project and you say Python -m, and then you say my v and space my virtual environment. Okay. My virtual environment. Okay. So what it will happen is Python is going to create a virtual environment where you can run your entire installations and all those stuff. Okay. What is the purpose of this? The purpose of this is that I want to be able to I want to be able to go ahead and I want to be able to go do all the installations within this environment itself. Correct. That is the beauty of a virtual environment, and that's what we're trying to do. Okay. Uh, if you don't use virtual environment, what happens is installations will happen everywhere. It might impact your core modules and all that stuff, right? So that's the benefit and power of virtual environment, and typically encouraged to do that by creating a virtual environment. Okay, sounds good. So once you have done this, the next step should be VNV. So I said it might. So on the left side, you can see, right? There is this my virtual environment. Can you see this over here? I expand this and press it. So my virtual environment. So typically what you have to do is this is just creating the virtual environment in your folder. It has not activated it. Next, you need to activate it. So how will you do it? You say my virtual environment /scripts/activate, because we are on Windows. Now you can see this green fun. This is what this means that the virtual environment has been activated, and you can now go and use pip install -r requirements.txt. Okay, cool. That's what it's all about. Okay, and then it will install all of them in this virtual environment. I just wanted to talk about that because there's an important concept. And after that, once it installs, you can run the file which is mentioned above, which is object detection demo.py. Okay, cool. So that's it, folks. That's all there is to it. If you have any questions I would like to answer, I'm happy. I'll be here for a minute. So if you want something, you can ask. Otherwise, I will encourage you to run it. It's very exciting. Computer vision is a very interesting area of AI. Okay. Yeah. Okay, Data Valley team, any questions? Are we good to go? Yeah. Okay, fine then. Thanks, everyone. Take care. I'll share this presentation with the Data Valley team. Okay. Take care. Bye.